Going to run through some of the logic of the initial approach for decentralization. Then we'll jump into our approach to threshold signatures, which has created, as far as we can tell, a 1000x increase on the efficiency of how large Oracle networks can interact with Ethereum. And we think the next iteration, which logically makes sense, is that as you expand the features, now all of a sudden you have the ability to build entirely new categories of contracts, and that's really the outcome that we're seeking to achieve. Is scale Ethereum in the sense that it can talk to all these inputs and outputs, and it can therefore be useful other environments and use cases to scale what Ethereum's capable of, but retain security. We've launched on Ethereum mainnet. Before we did that, we had 3 security audits. This is an example of a fully decentralized cryptocurrency derivative to provide a price input into a contract. This we have working on mainnet right now, and then this Oracle network can expand to 5, 7, 21, 52, is it 1,000? Is it 111? Is it 3? Is it 21? How many node operators do we feel independent Sybil resistant node operators do we feel we fundamentally need? They obviously need to pay, so that's another key outcome. So we've taken the cost down from $3,000 per verification to something like $1.50 or less. So it's orders of magnitude improvement.
What's going to be happening now, new data is going to be coming into all of the oracles. They're going to discuss amongst themselves what the consensus observation is. They're going to construct a signature between themselves, and then they're going to send that signed consensus data to the blockchain. The way we do that is with threshold signatures. So this is not magic. This is cryptography. It works. I've got it down to about 13,000 gas. Should be able to get it down to a marginal cost of about 7,000 gas.
Fundamentally, that's fundamentally if we can fundamentally speaking. There's another fundamentally.
Oh, my slides were cut off. Can I